As it turns out, one of the things that you can do with vectors is you can actually write the equation of a line using vectors. And so in this first slide, I sort of want to show you this new thing called vector form, and I want to draw some parallels to point slope form of a line. Right? So recall that with point slope form of a line, you need two things to write the equation of a line. You need a point that's on the line, that's x1, y1, and you need the slope of the line, which we're calling m. Right? So you plug those things into point and slope form just like this, and this gets you an equation in, like a Cartesian form or a point slope form. If you want the vector form of a line, you effectively need the same things. You still need a point on the line, but we're going to represent it as a position vector. Given this is vector form of the line, we're looking for vectors. So the point on the line we're going to write as a position vector. And the slope of the line, I'm not going to write as a slope anymore, I'm going to write as a directional vector. Right? And so the vector form is going to be, some vector r or l or any name you want, equals the position vector of the point on the line, plus t, sometimes they'll use lambda, sometimes they'll use s, they can sort of use any letter they want here, and then times the directional vector. And the idea here is that t is sort of the independent variable. T is representing time, and we can plug in time 0, or time 1, or time 2, or time 3, or time 17, or time 51 over 4. You can plug in any time you want, and if you work this out, you'll find another position vector for some other point on the line. Right? So just like in point slope form, if we plug in an x, we can get a y, and that gives us a point. Here you plug in a time, and it will give you back an x and a y coordinate for that point. Okay. The rest of this video is just examples of what we can do with lines, but the big takeaway here is that this equation here is the equation that we use when you want to write the vector form of a line. So my first example here, I want us to consider the line that's passing through the point 4, -1, and it's going in the direction of -2i plus j. So question A asks us to find the equation of the line in vector form. Well, we just covered that. We said that the line is supposed to be the position vector of a point on the line plus time times a directional vector. Right? Well, the position vector for the point that I have is 4, -1. The directional vector will be -2, 1, and you're done. Like that's the equation of the line. They gave me a directional vector in ij form, I just wrote it in column form. They gave me a point, I wrote the position vector of that point, and we're done. That's part A. Part B. Find the points on the line corresponding to times 1, 2, and 3. Right? So what this means is, they now want us to go back and say, okay, what happens when time is 1? Well, when time is 1, I end up with 2, 0. And so the point, note that it's asking for the points that correspond to those things. The point here is 2, 0. Right? So there is a point on this line which is located at 2, 0. We can do this same thing with 2 and with 3. You just plug in 2 here and solve that. Pause the video now, plug in 2 and plug in 3, and make sure you're okay with just the arithmetic of doing this. When I add these together, you get 4, -1 plus -4, 2. So that gives me the vector 0, 1, which yields the point 0, 1. Okay. For the last one of these, they want me to plug in time being 3. 4, -1 plus 3 times -2, 1. Let's see here, that's going to be 4 plus -6, so that's -2 and 2. And so that gives us the point -2, 2. So these are the 3 answers for part B, question B. Part C, find the value of t that corresponds to the point 18, -8. So what this means is, in part C, they're basically telling us, and notice in part B they gave us times and asked for a point. In this one, they're giving you the point and asking you for the time. Right? So you may want to make a note of this in your notes. For this problem, you're going to plug that point, which was, sorry, I just forgot it, 18, -8. We're going to plug 18, -8 into the equal side. I'm basically going to set my line equal to that. right? So I'm taking my equation of my line and I'm setting it equal to the point that I want to find out about. And you may want to make a note in your notes if you want to find out if a point is on the line or at what time you're at the point. This is how you do it. You set your line equal to the position vector of the point that you're looking at, and now we have to solve for t. Right? And this is sort of a weird thing because it's like, how do you really solve this? What I'm going to do is I'm basically going to break this equation into two parts. I'm going to break it into the x parts, and I'm going to break it into the y parts. Right? So I'm going to get one equation that says 18 equals 4 minus 2t. That just comes from using all the top numbers. 18 equals 4 plus negative 2t. And then for the other one, negative 8 equals negative 1 plus t. And the idea is, if this point really is on the line, these two values of t will be the same. It'll be, at time 5 or whatever, this is what happened. So now I can solve both of these things. For this one, I'm going to end up with 14 equals negative 2t, so t is negative 7. Okay, well maybe, let's confirm over here. When I move this over, and I add 1, I get negative 7 equals 7. Okay, that was a quick confirmation. Sure enough, for both of these, I find out that time is 7. So what does that mean? That basically means that the line is at the point 18, negative 8 at time equals negative 7. Now, I know a lot of people are like, oh, time can't be negative. Sure it can. That just means 7 seconds ago, 7 seconds in the past. Unless the problem states time has to be greater than 0, it's really not a concern. Okay? So, there's our answer. I know this problem's going on for a long time, but this is an important fundamental skill. Part D asked us to show that the point negative 3, negative 6 is not on the line. Given part C that we just did, I believe that you guys should be able to do this problem. So if you're feeling up to it, pause the video, work through it on your own. It should be pretty quick. So let's see here. I'm going to set my point, my position vector, equal to the equation of the line. And what I'm expecting to find is that when I solve for t here, I will not get the same value. So first I set my x parts equal. Then I set my y parts equal. Right? When I solve the left one, I get negative 7 equals negative 2t, so t is 7 halves. This one over here, I get negative 5 equals t. These are not the same t. Therefore, the point is not on the line. Right? It's as simple as that. Showing that a point is not on the line is that. Okay, so I know that was a long example. I actually have 2 more examples. The good news is that the 2 examples are exactly the same thing. I just wanted to give you guys a chance to practice this and make sure that you had the idea. So we'll move on and look at those next. So there is one slightly different thing about this problem. In the previous problem, I gave you a point on the line and I gave you the direction of the line. In this one, I'm stepping it up 1 difficulty level, not too big a deal, but instead I'm just giving you 2 points that are on the line. But now my questions are going to lead you through this. Part A asks you to find the vector AB. Everybody should be able to do this. This is not new to this lesson. This is old stuff, right? How do we find vector AB? Hopefully you remember that you do it by taking OB minus OA. If a problem ever asks you to find a vector, it's almost always going to be done like this. Right? So OB is the vector negative 4. That's a 4. Negative 4, 2, 5. Vector OA is 3, negative 2, 7. So if we subtract these guys, I end up with negative 7, 4, negative 2. Okay, so that's vector AB. Now part B just jumps straight to, okay, so hence write down 2 different equations for the line passing through A and B. Remember, if you want the vector form of a line, you need a point on the line, and you need a directional vector. Now the idea is, if you've got a point A and a point B, and there's a line that's going through them, wouldn't you agree that the directional vector for the line is AB? Now in the same breath, somebody might say, well, I thought BA was the direction. Fine, either one of them. It doesn't matter to me. Right? Either one of those could be the directional vector. Right? I asked you to find AB in the problem, so hence use AB as your directional vector. Okay? So we'll sort of do that next, right? We're supposed to write 2 different equations. So I can get 2 different equations by using these different points. Right? Right? So for one of them, I'll say that my point was 3, negative 2, 7, plus t times the directional vector, which is negative 7, 4, negative 2. And then for my other one, I could say that the point we're going to use is negative 4, 2, 5, plus t times negative 7, 4, negative 2. The idea is in both cases, all I'm doing is writing the position vector of a point on the line with the directional vector. A different point that's on the line with the same directional vector. Either one of those would be correct answers. So now part C, they want us to determine if these points are on the line. Right, so that should be an easy thing for you to do based on what we did in the previous problems. I'm just going to, before you pause the video and try it on your own, I'm going to let you know when I do this problem, I'm going to use this line to do it. To be honest, you could do it with either one of them. Your answer might be different, but you'll still find that they are or are not on the line. So just as a heads up, I'm going to use that first line. Alright, so here we go. Part C. The 2 points they want me to look at are 17, negative 10, 13, and the point negative 11, 6, 3. So I'm just writing them there so that I can scroll down past them. Okay, so for that first one, I'm going to set 17, negative 10, 13 equal to 3, negative 2, 7 plus t times negative 7, 4, 2. And I'm gonna hope that I can sort of fit both of these here. So I sort of set the x parts equal, that 17 equals 3 minus 7t. Set the y parts equal, negative 10 equals negative 2 plus 4t. And I'll set the z parts equal, 13 equals 7 plus 2t. I think I did all those right, yeah. So now I'm just going to solve each one of these things, right? So when I solve that black equation, I end up with 14 equals negative 7t, so times negative 2. Okay, there's one possibility. We go on to the red one, negative 8 equals 4t, so t is again negative 2. Things are looking good. 2 of the coordinates matched up. For the last one, I'll subtract this over and get, that's actually positive 6 equals 2t, which means t equals 3. Okay, so is point C on this line? No, C is not on the line. And the reason is I got different values of t. 2 of them matched up, but the last one did not match. Right? So it's not on the line. Now we'll try the other one. You'd argue that by process of elimination, this one probably is on the line. Okay, you're probably right, but let's actually do the math to find out. If you didn't pause the video to do the last one on your own, definitely pause this one and try it. So let's see here. I've got negative 11 equals 3 minus 7t, and then I've got 6 equals negative 2 plus 4t, and I've got 3 equals 7 plus 2t. We'll solve these three guys. That's negative 14 equals negative 7t, so that's time 2. For this one, I've got 8 equals 4t, t equals 2. Alright, so things are still looking up. And then here I get negative 4 equals 2t, which means time is negative 2. Ooh, I surprised you guys, or I surprised myself. So it turns out D is also not on the line. Right? What does it mean for the point to be on the line? It just means that all three of those time values have to be the same. Okay, so unless I made a mistake in there somewhere, which is possible, it does not look like either of those points was actually on the line. This last problem is really just sort of a condensed version of the previous example problem, so if you'd like another practice problem, go ahead and do this one. Otherwise, there's nothing different about this one. In some sense, this really isn't necessary if you understood everything that we did in the previous problem. So I'm going to do it really quickly here. I'm not going to explain my work nearly as much because we explained it in depth in the previous problem. So to find the equation of this line, I need to have a directional vector. So vector AB we'll get by doing OB minus OA. That vector will be negative 1, 3, negative 2. So that means the equation of this line will be R equals a point on the line. You can pick either one you want. I'm going to go with 5, 2, 2 because they're all positive, plus time, and then negative 1, 3, negative 2. If you decided that you wanted to use this other point, that's absolutely fine. There's nothing wrong with it. It's good, right? So this is one of the correct answers for A. For question B, determine if those points are on the line. So again, I'm going to write these down. I've got 2, 11, negative 4, and I've got 11, negative 12, 12. Just like we did in the previous problem, we just set our line equal to these things and see what happens. So if I set 2, 11, negative 4 equal to 5, 2, 2 plus t, negative 1, 3, negative 2, that'll be for that one. For the other one, we'll have 11, negative 12, 12 equal to 5, 2, 2 plus t, negative 1, 3, negative 2. And then just like we did on the other ones, we sort of set each part equal to one another. So we have 2 equals 5 minus t. Then we have 11 equals 2 plus 3t. And finally we have negative 4 equals 2 minus 2t. If I solve these guys out, I end up with negative 3 equals negative t, so t is 3. With this other one, I end up with 9 equals 3t, which means t equals 3. Again, suspense is building. We're wondering if we're actually going to get a point here. This is negative 6 equals negative 2t. Hey, we win! We found one! It turns out that this point is on the line because all three of these values of t were the same. For our other example, 11 equals 5 minus t, and negative 12 equals 2 plus 3t, and 12 equals 2 minus 2t. If we solve these guys, we're going to end up with 6 equals negative t, so t is negative 6 for this one. For this one over here, we'll have negative 14 equals 3t, which means t is negative 14 thirds, and I don't have to go any further because those times already don't match. So D is not on the line. Okay, and that's the end of this video. It was a long one. Sorry. See you in the next one.